All right, today we are talking about concurrent vectors, and we are going to be working toward solving vector problems when they occur at the same time. That's what concurrent means in this. And so let's see. So some vectors are added one right after the other, so sequentially, and others are applied at the same time or concurrently, and it doesn't matter which one, the resultant is the same because you get it by adding them head to tail. So for these problems, you're going to have two types of problems. So it's two types of problems put together. So you have a boat sails straight across the stream, and then the boat is pushed up or downstream. You will also see these with helicopter or airplane problems. It's the same type of problem, just different scenarios. So here is our example problem. I'm going to work this out the long way first, then I'm going to show you how to make it much, much shorter. So it says a boat heads directly west across a river 40 meters wide at 8 meters per second. The current is flowing at 3.8 meters per second to the north. What is the resultant velocity of the boat? How long does it take to cross the river? How far downstream or up is the boat when it reaches the other side? So if you notice over here on the right are a bunch of vectors that we need to put together. So I'm going to draw a rather large triangle so that we can fit everything. This here is 3.8 meters per second. This is the velocity of the river. So I'm going to say V sub r, and it's 3.8 meters per second. Then this is 40 meters. And if you notice, this is a distance, and I'm putting all the distances on the outside and putting all the velocities on the inside. Okay, and then this is a velocity, V sub b is the velocity of the boat, and it's 8 meters per second. And then we end up with our resultant. So the river is going to push our boat north, and it's going to change its velocity as well. So we want to find out the velocity of the river plus the boat. So it's the boat's new velocity. So it says the resultant velocity of the boat. So I'm just saying V r plus b because that's the subscripts we used before. The velocity includes the direction, so we do need this angle as well. We will need to find the distance across here in order to find the time, and I'm going to show you that in a second. But first, we can do the easy part first. We can find this velocity, V r plus b, V r plus b. The velocity of the river plus the boat is just going to be a squared plus b squared equals c squared. So because this is a 90-degree triangle, so it is 8 squared plus 3.8 squared, and then we take the square root of that. Okay, so then that is 8.85 meters per second. So we can put that here. Okay, so then we also need the angle. So this, I always use the knowns, the things that were given to me in case I messed up my math. So then this is going to be opposite over adjacent. So opposite over adjacent is tangent of theta is equal to, the opposite is 3.8 divided by 8. So then we have, to get theta by itself, we do inverse of tangent times the inverse of tangent. So that is equal to 25.4. 25.4 degrees. So then our our velocity of the resultant velocity, so we can say the resultant velocity, which is the velocity of the river plus the velocity of the boat, is equal to 8.85 meters per second at 25.4 degrees north of west. So that is this one here. Okay, so then distance is the next thing that we need. And to get that, we can say it is adjacent over hypotenuse. And we have this angle here. This is now 25.4. So we can use that because they're the same. They're similar triangles, but so the angle doesn't change. So we can say that it is now adjacent over hypotenuse. And that's equal to cosine of theta is equal to 40 meters over d. Yeah, you can label it whatever you want. But then this is going to be cosine of 25.4. And we can say that that's equal to 40 divided by d. And now we just need to swap places with cosine of 25.4. So 40 divided by cosine 25.4 is equal to 40, is equal to the distance that we're looking for. And then this distance becomes 44 meters. Now, if you notice, we have distance here, and we have the distance of the river plus the boat. So this is really the distance of the river plus boat, just to be consistent. So now, if you remember our equations, what is velocity? It's distance divided by time. There's no acceleration here, so we're just working with distance and time. So now we can solve for distance because we have distance. I mean, we can solve for time because we have distance, we have velocity. So the time is going to be distance divided by velocity. So then it's 44 meters divided by the velocity, which is the 8.85 meters per second. Okay, so this is then it's actually 5 seconds. So this is 5 seconds. Okay, so the reason I said that this was the long way is because we can actually take a shortcut here, and it's going to be the same thing, the 5 seconds here. If we go and find the distance the long way, the distance of the river plus the boat, as it is to realize that the time is going to be the same for the boat to just simply cross the river without the stream. So I'll show you what I mean. So I'm just going to change colors so we can see better. So this distance and this velocity, we can do the exact same thing. The velocity is equal to the distance divided by the time. It's going to take the same amount of time for the boat to cross the river without any current acting on it as it is with the current. So the time is still equal to distance divided by velocity. The distance this time is 40 meters divided by the velocity, which is 8 meters per second, and you get 5 seconds. So you can skip this middle part that I just showed you, but that's where you get that. That's another way to get the 5 seconds. The only thing linking both things is the time, because what happens is, sure, this is a longer distance, but it also speeds up the velocity, so it keeps the proportion the same. All right. So then how far downstream or up is the boat when it reaches the other side? So now we just have to find this missing side right here. This one was 44 meters. So it's just Pythagorean's theorem. I'm going to change colors again so we can see again. Actually not green, but maybe dark blue. So then it is c squared equals a squared plus b squared, but it's 44 squared is equal to 40 squared plus a squared. So then it's 44 squared minus 40 squared is equal to a squared. So then we had the 44 squared is equal to 40 squared plus a squared. And then we found that a squared is equal to 44 squared minus 40 squared. And that gives you 18.33 meters. So this right here is 18.33 meters. So it got pushed upstream 18.33 meters. And that's when the boat reached the other side. So that's how far up it went. So that's how you do these types of problems. Thank you, and we will definitely be working on this in class.